This is Lab Medicine Rounds, a curated podcast for physicians, laboratory professionals, and students. I'm your host, Justin Kreuter, the bowtie bandit of blood, a transfusion medicine pathologist at Mayo Clinic. As the temperatures turn cooler and we've gotten some snow here in Minnesota, we decided to travel south and connect with some of our colleagues at the other Mayo Clinic campuses over these winter months. Today, we're rounding with Dr. Jaramillo, an associate professor of laboratory medicine and pathology at Mayo Clinic and director of the Histocompatibility Laboratory at Mayo Clinic, Arizona. As we head into this holiday season, we think it's really appropriate that we're putting focus on the ultimate gift, organ transplantation. Thanks for joining us today to discuss this very important topic, Dr. Jaramillo.
Thanks, Justin, for the invitation. I'm really excited to be here.
So, what's your origin story? How did you first get interested in the ultimate gift? How did you first get interested in supporting
Mm.
organ transplantation?
Well, this is a long story, but I'm gonna make it as short as possible. Of course, we have only 20 minutes. But in college, I always wanted to go to medical school, and then I was quite interested in immunology. And I remember that the HLA class it was fascinating. I thought it was the most fascinating class I ever had, and because the HLA system is actually the most complex system that we have in the genetic systems of the human genome, because he has right now 32,000 different variants. So I thought it was just amazing that. And HLA, obviously, for the immunology class, was all the class is told to transplantation, not really for the function of the HLA system. So anyway, it happens that in the 1980s, my brother was diagnosed with a kidney disease. I mean, we knew that his kidneys were going to eventually fail, and his kidneys did. So he needed a kidney transplant in 2001. So actually, I was actually believe it or not, quite excited to kind of have this opportunity to give my brother a kidney. So we are five siblings, and it happens that I was the only one that was not completely genetically compatible. So my little sister gave him a kidney, and I always thought, as you say, this was such a gift of love, but also the gift of science. I mean, it is a true miracle because we have this person that is close to me that 20 years ago he got an organ for my sister and he lived a wonderful life. I mean, he's a retired lawyer now. Still, I mean, that was to me was amazing, and I always all these years I felt that I kind of missed out, in somehow in being part of that thing. So it's of giving him my own kidney. So that was I always thought that it was just fascinating. That's my a very personal story that I have.
Yeah, I love that. A very personal connection to this. And also, I love that it highlights the fact that, this is really one of these places where the basic science research really informs the clinical practice in a very direct way.
Correct, yeah, and so that geared me out actually of medical school. I was going to medical school and I switched to basic science to get my PhD because I really wanted to focus on the transplantation part of medicine. Really, I mean, more direct involvement in the genetic analysis, and I felt that I could help the patients more, more directly, even though it sounds kind of weird because I don't see him, but I feel that I could do a better job in the lab, you know,
Mhm.
doing that.
We've got a very diverse audience on this podcast. We've got physicians, we've got laboratory professionals, we've got students that listen to this. Maybe could you kind of give us a flavor for what are the organs that we actually
Yeah,
can transplant?
yeah. Well, for there are the two types of donors, of course. The deceased donors, you can actually get a heart, of course, from a deceased donor. But from live donors, I mean, you can live donors can donate bone marrow, of course. You can donate one of your kidneys, one full lung or part of your lung, part of the liver, of course, and a part of the pancreas and part of the intestines. You know, a healthy person can donate literally 6 organs. You know, if we count bone marrow as an organ as well.
Mhm.
So it is a long list of organs, and donors can live a healthy life after that.
So I guess for people that are interested in potentially becoming a donor, giving this gift,
Yeah.
I guess for a deceased donation, it seems like when we are at the Department of Motor Vehicle, we can register as a donor. Is that
Yeah.
right? And then make our wishes known to our family.
Correct. Yeah. That's uh that's how yeah, that's pretty much the best way of doing it. So you are actually are in the system. Otherwise, at the time of of your eventual death by an accident, there there may be some emotional issues when the family when somebody asks in the hospital to the family, say, hey, there is a possibility that your loved one can be an organ donor. However, you are approaching the family in a very probably the worst time of their lives. That is very tough for them to make a rational decision at that moment. So yeah,
Mhm.
the best way is to just have your wishes kind of register in your license. Yeah.
I see. And then if people are interested in donating, let's say a kidney or something, for example, is that just reach out to their local hospital and let them know that they're interested in being a donor?
Correct. Yeah, most live donors. There are about 6,000 live donations in the United States every year. Last year, for example, but occur from a family member to a family member. But many people just feel that they need to donate a kidney, or obviously there are many people that register as bone marrow donors.
Mm,
So, but yeah, if you feel that you want to donate, it's usually a kidney, of course, because it's the kind of the easiest, the the less risky organ to give. People just come to the hospital and say, I want to be a donor.
mhm,
I want to donate my kidney. I'm healthy. I want to give this, have this gift to somebody that will need a kidney. Otherwise, that person will continue to have a pretty horrible life on dialysis, and dialysis is not a healthy way to live.
mhm,
So they do. I mean, these people that do have a convictions, they come in to do it.
mhm.
So it's
So we'll put a couple links down there for those that are listening, helpful links to kind of get in touch if you're more interested in more information. I'll put links to National Marrow Donor Program and that kind of information. Uh, Dr. Jaramillo, how does your work in the histocompatibility laboratory, in the broad strokes, how does it support transplantation?
Yeah, the HLA lab is actually, even though we do complex analysis, it's actually quite simple. We really literally do two things. We do an initial genetic analysis of the HLA system, the genetic system of 11 genes, and used to have kind of an initial assessment of the genetic matching between
Mhm,
the recipient and the potential donors. And that's kind of a minor risk assessment. I mean, if you happen to have a good match with the kidney donor, that's great. If you don't, it's not a contraindication to transplantation, but your risk assessment on having a rejection down the road is a little higher, just as, very, very, very low. Then the most important thing is that we do an immunological analysis of your antibody profile, and that is really kind of what the when the matching happens. Because if you have an antibody present against that donor, then you will have a rejection of that organ. So we make sure that if you have antibodies, we avoid those antibodies and to pick a donor for which that patient doesn't have any antibodies and guarantee that that organ is going to last several years. So that's literally what we do, you know.
I see, and I imagine that it sounds like it sounds like you're probably not giving yourself enough credit as you talk about more than 32,000 genes. But it sounds like you're really interacting with a number of different physicians, nurses from different specialties. Could you kind of give our audience kind of a flavor of how does this work to do this kind of dance to match donor and recipient and have a successful transplant?
Well, for live donors, we do have time. I mean, to type the entire families, and then we can actually pick and choose in a timely manner the best donor for that patient based first on the antibody profiles, and then if your siblings are a full match, that's perfect. For deceased donors, we need to do this in a very fast way.
Mhm.
So we actually type the donors, in a what we call a stat, within 3 hours, and then by a computer analysis, because it's almost impossible to do it by hand. We do the antibody profile against the genetic profile of the donor to try to find out what is the best at this point. If it is a disease donor, we try to find out what's the best recipient for that donor, and not the other way around.
Mm.
So a recipient that doesn't have antibodies against that donor. So that's basically what we do. So it's basically a genetic profile against antibody profile of the recipient, and we just try to find kind of the best holes in the antibody profile of the recipient. You know.
Wow. It strikes me too that, as managing this and getting it right and getting it as best as possible. And there's all kinds of ethical challenges to navigate as well. I'm kind of curious, what's your thoughts for what's on the horizon for HLA and histocompatibility in the next couple of years, you think?
There has been very rapid developments in the molecular assays that we do, and has been happening in the last 3 years. That we are getting right now, slowly getting into all the HLA labs in the country and in the world, better better testing, molecular testing for the genetic analysis that we do of the donors. So that is happening right now. And also we are getting better kind of what we call high resolution testing of the antibody profile as well. So we can actually, I think we are getting better and better in having a better profile analysis of the genes that the donors have and of the antibodies that the patients have, so we can actually have a kind of a better assessment, risk assessment, and that way we can actually get organs to patients that are highly sensitized, meaning that they have a very wide profile of antibodies. We can actually, with these new tools, find these people the right donor, the right organ. That is internally what is happening in the HLA lab. In transplantation, though, I think the field of xenotransplantation is being that concept has been around forever. So it's basically xenotransplantation is transplantation from a non-human, from another species, and actually the best species to get organs from is the pig, because the pig actually you can have some breeds of pigs that are in between 120 pounds to 200 pounds, so their physiology is very similar to humans. They have the pretty much the and the size of the organs are quite similar. So if you have a patient that he weighs 180 pounds, you can find a pig that weighs 180 pounds. The kidneys, the heart, the livers are going to be basically exactly the same size. So it's perfect for that patient. But only until now, I mean, last year in John Hopkins, there was really the first pig to human experimental transplant, and it was successful because this is a genetically modified pig where they actually were able to reduce the expression of the HLA of the pig, which is called SLA, swine leukocyte antigen. In humans, is human leukocyte antigen. In pigs, is swine. It is called SLA. They were able to maintain this kidney in an experimental uh, brain dead patient for several days. So that was really, really exciting. That is not going to replace, it's not going to get us out of business, but we'll give an organ to these patients that I have mentioned before that have a very large profile of antibodies for which it's basically impossible to find them a, a good human donor in the donor pool.
So what I hear you
So
saying, correct me if I'm misunderstanding, is that the xenotransplantation you see as like really a bridge to get us a little further down the road to when we might find the definitive transplant?
it could be a temporary bridge, yeah, until
Hmm.
or depending on how good the genetic manipulation of the pig, it could be forever. I mean, it could
Hmm.
be a permanent organ that person can have. Otherwise, that person would never find a human donor for it.
Hmm.
So I personally was really excited about it because I remember writing papers about this back in the 90s, and it was like, oh, it's gonna happen next year, and it never happened because it's so complex. So now it really happened. So
Uh,
it was.
That's wonderful. So, and then I guess the other part you were talking about what's happening in the laboratory about getting better molecular assays, getting a better antibody profile. You were highlighting that then it's going to be uh, the ability for us to identify a patient that's highly alloimmunized. It has lots of antibodies. These patients who used to not be able to get a transplant, you're saying is now getting the transplant because of these improvements in the laboratory.
Yes, correct. Yeah, we it's basically trying to have a very small hole that we couldn't see before. Like a small window.
Yep.
So if you don't have any antibodies, the window is as big as a door. If you have a lot of antibodies, you literally have no window. So now with this new test, we can actually find small windows to that possibility, and that is very exciting. We are actually seeing that now in the practice that we're able to transplant these people that have been waiting for a kidney for 10 years, but now that we can actually do it. We can actually find them a donor. So that is, and the test is getting better. Not necessarily better in resolution, but faster. So
Hmm.
that's the thing. That we can actually type a deceased donor in high resolution in a timely way, and
Hmm.
then do it.
Well, that's wonderful. I think, my sense is people that are on the donor waiting list, things that are happening faster are exciting developments to have.
Yes, correct.
So thank you so much. We've been rounding with Dr. Jaramillo talking about the ultimate gift of organ transplantation. Again, in the show notes, we're going to have some links to some of the organ transplant organizations here in the United States. And we'll also have a link to that paper from Johns Hopkins that Dr. Jaramillo mentioned for us. Thank you so much, Dr. Jaramillo.
Terrific. Thanks for having me.
To all of our listeners, thank you for joining us today. We invite you to share your thoughts and suggestions via email. Please direct any suggestions to mcleducation@mayo.edu. If you've enjoyed Lab Medicine Rounds podcast, please follow or subscribe. And until our next rounds together, we encourage you to continue to connect lab medicine and the clinical practice through insightful conversations.